Hello, eighth graders. So we are starting with our first rock we're going to focus in on, and that is our igneous rocks. This picture explains igneous rocks absolutely perfectly because you cannot have an igneous rock without having some sort of magma or lava, things like that. So let's get into it. We are looking at Middle School Earth Science Standard 2-1, which is the same as our mineral one, but we're going to take it just a tish of a step further. So develop and use a model to describe the cycling of Earth's material and the flow of energy that drives this process. Okay, so we're focusing in mainly on that, but our clarification statement states that emphasis is on the process of melting, crystallizing, weathering, deformation, and sedimentation, which act together to form minerals and rocks through the cycling of Earth's materials. So what you're going to be able to do by the end of today, okay, is you're going to be able to define characteristics of rocks. There are certain characteristics of all rocks that we kind of sort of touch on throughout this. You'll for sure get the rest of the answers throughout our next two lessons. You'll be able to identify the three types of rocks, but today we're going to focus in on just igneous rocks. And then finally, describe what an igneous rock is and the process in which we actually get igneous rocks. So, make sure you have your whole group notes in front of you for sure, if not all your notes. So let's talk about what must happen for an igneous rock to form. In order to get an igneous rock, and this is just where I like to personally start, you can start anywhere with whatever type of rock you want, but to me this makes the most sense in my head. Don't ask me why. In order for you to have an igneous rock, you must have a completely melted and liquefied rock. So molten rock, either lava or magma, must be cooled and then crystallized. Now, there is a difference between lava and magma. Okay, I think I got like on someone's case about this and everyone's like, what's the deal, G? This is the deal. So lava is magma, but at Earth's surface. This is when it erupts out of a volcano, when it is seeping out of a fissure. It is physically making contact with our atmosphere. Okay, magma is when it is the molten rock below Earth's surface, where it has yet to come in contact with any of Earth's atmosphere. Okay, so magma is below, lava is above, and I am going to be picky about that, just like I was picky about y'all calling my minerals minerals and not rocks. So, sorry, not sorry. Because of having this definite line between what is magma and what is lava, that is what then brings us into our two different types of igneous rocks. So we have intrusive igneous rocks and extrusive igneous rocks. So let's break it down a little bit. So intrusive, meaning in, into, on, upon. This is you have to think of like interior. Invertebrate. This is something that is inside something. So any intrusive igneous rock is found within Earth's surface. This means then that this is cooled down magma, not lava. Okay. Extrusive igneous rocks, its root ex means out of, from, upward, completely, derived of, and without. So think of exterior, so the exterior of your home, an exoskeleton or a skeleton on the outside of the actual like body. So an extrusive igneous rock is an igneous rock that has been cooled and solidified at or above Earth's surface. Has to be made of lava. So it's nitpicky, but it's what's necessary. So understanding those differences really does help. That's it for whole group. So Make sure that you remember your champ's expectations, voice level 0 to 1. If you need any help, read the directions, reread the directions, ask someone, and then raise your hand for teacher support. Your activity today is just notes. There is an exit flip at the end of this, so make sure that you are completing that as well. You should, for the most part, be kind of within the spot that is most conducive for your learning. But if you need to move around because you have some chatty Cathy's next to you, please do so. Make sure you get your notes turned into the tray or online, and then complete your exit slip. Okay, if you're sticking around for the rest of the notes, fantastic. If not, see you later. So where do extrusive igneous rocks form? Well, extrusive again, meaning exterior on the outside. That means that it has to be lava. And as we've already defined lava, lava has to be at or above Earth's surface. So extrusive igneous rocks are formed where volcanic material has erupted and cooled. So above Earth's surface. Some phenomenal examples of this would include obsidian, which is the top picture. This is where lava has cooled very, very quickly, which forms this fine grained texture. If you were to touch even like the exterior of an obsidian rock, it's very soft. So when I'm talking fine grained texture, I'm saying you can rub it against yourself and you're not going to really like pull away any sort of like skin sort of a thing. On the inside, after you crack it open, you see this, you get volcanic glass, or dragon's glass, depending on what form of fantasy you are into right now. And this is a super fine, super small crystalline structure where it's glassy or glossy because of its crystals with the minerals that are found within it. That obviously, if you touch it, is very, very smooth. I should have some examples of all the rocks that I'm talking about up at my front lab station if you wanted to go and touch and feel, because I feel like when I say fine grained texture, you really don't know until you're actually like hands-on. Okay. Pumice. This is when magma cools and it traps volcanic gases. So if you've ever used a pumice stone, not saying that men don't do this, but typically it's my ladies. If you've gone and gotten a pedicure, they typically take a pumice stone to your heels. Maybe not. Maybe I'm just old and have rough, nasty feet. I don't know. But it is literally this rock. It has a very coarse grain texture, meaning that when you rub it against yourself, you will take up some, like, I hate saying skin, but you just take up skin cells, sort of thing. The dead epidermis layer will come off if you rub it against it. Again, I should have some examples at my front lab station if you wanted to go and touch. Pumice is really cool as well because it's very, very light. Because it has trapped in so many of the gases, it's formed these little holes and crevices that allow it to be very light. It floats on water, which is really kind of cool, especially when you think like, oh, it's a rock, rocks sink. Will is into a big sink or float sort of thought process right now, and he would normally say, oh, this is going to sink because it's a rock. But it doesn't, because it has so many volcanic gases trapped inside that it makes it very, very light. So what are some characteristics of extrusive igneous rocks? Extrusive igneous rocks, typically you're going to find around volcanic activity. So the islands of Hawaii, Mount St. Helens, places like that, the rocks take on the characteristics of the lava for that area. So if the lava happens to be very ashy, so like the eruption of Mount St. Helens in 1992, your rock is going to have a lot of that ash trapped within it as well. If the lava has a lot of gas, it's going to contain a lot of gas as well. That's where you get your pumices and things like that. If your lava cools fairly quickly, which most extrusive igneous rocks do, you get very, very small to no crystals because it hasn't given the crystals of the minerals time to actually form. Obsidian has very, very small crystals versus pumice and tuff, which I'll show you a picture of here shortly, don't have any because there just was not enough time for the minerals to truly set up and form those crystals. So you have tuff, which literally looks like thrown up rocks stuck together, sort of a thing. That obsidian in the center, and then pumice off to, if you're looking at your screen, it's your right hand side. So those are all examples of extrusive igneous rocks. So where do intrusive igneous rocks form? Well, intrusive, remember in again being like interior, inside. So it is going to be cooled magma that gets kind of cut off from its heat source and is given time to slowly cool deep underground. Now, the thought process is, oh, well, how do we know that it's in there? Da, 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 da. Well, because over the course of time, plate tectonics, weathering and erosion, things like that, they become exposed. So after it is cooled, this picture from our book actually shows it the best. So if you look down here, you have your magma source. And as it comes to the surface, it cools extensively, very, very quickly, and you get things like basalt, but it's cooled up here. Now, what happens over here with like this granite is if this magma source were to be cut off because you've gotten other layers of rock and stuff caught up in between it and the core, which keeps everything warm, and given enough time, it cools. Now, either through pushing of plate tectonics or weathering and erosion, so taking away layers of the surface, you then expose this granite. And the really super cool thing about intrusive igneous rocks is that they have gorgeous crystals. Let me show you. So you get very well-defined crystals because it has enough time for that magma to cool super duper slowly, which lets the minerals take their time. Lots of lots of quartz and mica and things like that have time to actually set up and start building their structure so that you can see these well-defined crystals. So the texture of intrusive igneous rocks usually are quite coarse, meaning they're kind of chunky looking. So you get examples like the diorite, which to me, for whatever reason, is like Dalmatians. Diorite is this black and white crystal. You can see that it's chunky. You can see the bits of mica in the black. You can see the bits of quartz in the white milky color. Like that coarse material or that coarse texture is the way it looks. It looks chunky. And then you get granite, which tends to be more pinky stoned, more of your rose quartz sort of thing with your mica and stuff thrown in there. But again, you can see the distinct difference between the pink and the white and the black. So that's what I mean by coarse. Okay. So how can the texture of an igneous rock suggest where it's formed? So if I were to lay out 6 different examples of igneous rocks, you should be able to tell me just by a quick look, or maybe not tell me, but make an educated guess as to whether it's an intrusive igneous rock or an extrusive igneous rock, based off of how they look and feel. So a rock with a smooth texture more than likely doesn't have crystals, because we can then assume that it wasn't given a lot of time to cool. This is what actually becomes your extrusive igneous rocks. They're cooled very quickly. As soon as something really, really hot meets our cooler atmosphere, it starts to solidify. It doesn't have enough time to actually gain crystallization. So extrusive igneous rocks cool very, very quickly above Earth's surface, preventing crystals from actually forming. So if you were to be like, oh, this is extrusive, 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 but the way you can then tell, oh, the other three are intrusive, it's because the rock seems to be very coarse in texture. You can see well-defined crystals because it had time to form. Intrusive igneous rocks have to cool slowly because the Earth's crust is like a big old blankie around it. So yes, it is much, much warmer than the crust itself. But once you take it away from its heat source, the crust kind of engulfs it and cools it down to what we can stand on with our bare feet, sort of a thing. But it cools it down at such a slow rate that it allows those minerals to form its crystallization and all this. That's why people love granite countertops, because of all the little sparkles, things like that. But yeah, so if you were to be able to look at some rocks, you should be able to tell. If I said all of these are igneous rocks, you should be able to roughly tell me which one would be intrusive and which would be extrusive. I'm not asking you to name rocks quite yet. We will get there. But you should be able to just based off of how it looks and feels. Now, what we also have to take into consideration is the coloration of an igneous rock, okay, and how it relates to its composition. So 2 more terms that you're going to need to know are the terms felsic and mafic. Now, felsic sounds very like light and chipper, and that's the way that that rock is. It's a very light in color. Typically, it's your light pinky reds to your whites, things like that. And that is because felsic rocks contain a lot more silica, which means that it has a lot more quartz crystals. Okay, mafic, I don't know what it is about the MA. It's such a like whoa sort of sound, but mafic is dark colors. Typically, it's those like darker reds to browns and blacks, and that's because they tend to contain far more of the heavier elements like iron and magnesium, which just makes them that darker color. So obsidian, very, very heavy in iron and magnesium, especially depending on where it is erupting from. Iceland has far more iron and magnesium than, say, Hawaii. Still a lot of iron and magnesium, but not as much to where a lot of Iceland, when the volcanoes finally cool or the lava's finally cool, it's very, very dark. Versus in Hawaii, it can be very light in some places because it has a little bit more of the quartz within it. Whole new geography lesson. But mafic, just remember, is very dark in color because it has those heavier elements. Felsic is very light, so it has a lot more of that silica quartz sort of thing. So, in a good 20 minutes, if you start from the beginning to the end here, that's igneous rocks. Main things to take away: has to have some sort of magma or lava involved. Intrusive versus extrusive, felsic versus mafic, and then being able to look and see, well, if the crystals had time to form, it must be intrusive. If the crystals did not have time to form, it has to be extrusive. That sort of a thing. So yeah, those are the big things to take away. And then we will start combining all of this information together and creating our rock cycle in a couple of weeks. So questions, comments, concerns, please come and chat with me. I want to be able to answer those for you. Yeah, awesome. Let me know if you guys need anything. Remember your exit ticket. Awesome. Thanks, guys.